Welcome back. Now today we're going to focus on 7-2 again, but on day 2 we're going to focus on strictly numerical bases. So yesterday in class we focused on variable bases, and in the last video, and we've really taken about 2 days in class and a video to really get that down. So this should be a little easier transition, and then in tomorrow's video we're going to put it all together. So today we're focused on just numbers. So let's start with example 1. Now, the cubed root of 48. So, as we're breaking this down now, when we do square root of some number, remember we always look for pairs. That's not 12. 6 and 2, 3 and 2. We would pull out a pair of 2's because there's a 2 out here, and that would give me 2 root 3. Alright, so when we have cubed root, we're looking for 3's. So let's start breaking down 48. So I got 2 and 24. Let's go 2 and 12. And then 2 and 6, 3 and 2. So every pair of 3's come out as 1. Well, in this case, I have 3 2's. So that comes out as 1 2. And I have a 3 and a 2 left on the inside. So whoever's left alone stays in. And we multiply those. So 2 cubed root 6 is your solution. Alright. Now think about that. The perfect cubed root, 2 times 2 times 2 is 8. And the cubed root of 8 is 2. So that's what we pulled out. That's why we have to have 3. Alright, let's try another one. Now we're going to multiply. So let's go the 4th root of 4 times the 4th root of 8. Now, since they're the same, you can multiply them and combine them. So the 4th root of 4 times the 4th root of 8 is the 4th root of 32. Now, in order to pull anything out here, I'm going to need 4 of a kind. All right, here we had 3 of a kind. Now I'm going to need 4 of a kind. So let's go 2 and 16, 2 and 8. 8 is 2 and 4. 4 is 2 and 2, so lots of 2. So I need 4 of a kind. Well, there's 4 of them right there. So all 4 come out as 1. 2's left alone, he stays in. Don't forget it's the 4th root. If you forget to put your tiny little 4 there, it's wrong, because then you're saying the square root. And that is a different value. Alright, now, we did this with variables, and I did a lesson in class because I thought it was a little confusing. And that's rationalizing. Alright, so try to draw on the knowledge when I talked about it in class. And we said we have a cubed root of 2. So that tells me how many 2's do I need? I need 3 2's. Alright, so that means when I multiply, I'm missing the cubed root of 2 2's. So 2 squared, because that gives me 1, 2 2's, so 2 2, and then a third 2. Alright, whatever you do to the bottom, you have to do to the top. So when you multiply straight across, you get 5 times the cubed root of essentially 4, because 2 squared is 4. Then down here, I now have created a perfect cube, right? Because I have the cube root of 2 to the 3rd, which is just 2. So I have 5 cubed root of 4 all over 2. Now, in the event this was like a 6, you could divide those two and put 3 cubed root 4. But because these two aren't divisible, you got to stop. Numbers with numbers, roots with roots. Alright? So not so bad. Now that we took the time to do it in class already, you should have a better sense, a conceptual understanding of that. Alright, let's go to example 4. Now we're going to add and subtract. Now again, if you remember back from Algebra 1, okay, if you had like 4 root 2 minus 7 root 2. Because they were both root 2's, you were able to combine the numbers in front. But if you had like 4 root 3 plus 8 root 2, you were not able to add those because they had different square roots, so you would keep it the same. It's like combining like terms. Alright, well the same rule applies here. Okay. We have cubed root 7, therefore you can combine the coefficients. So let's say we have 2 minus 5 is negative 3, cubed root 7. If you could break that down further, you would, but we can't. So stays as is. All right, what about this one? Cubed root of 375 plus cubed root of 81. Now, right off the bat, you don't think, look, nothing similar, can't add or subtract them, but be careful. They can be very, very sneaky. All right, so we got to break them down because they can be in disguise. So 375 is what? 25 and 15. 25 is 5 and 5. 5 and 3. I'm looking for 3 of a kind. I got 3 5s. So I can pull out my 5 and cubed root of 3 stays. Plus 81 is 9 and 9. 3 and 3. 3 and 3. I'm looking for 3 of a kind. Pull out my 3. Cubed root of 3 is left in. Now looking at them, can they be combined? They sure can because they have the same cubed root. So 5 and 3 give me 8 cubed root of 3. All right. Let's try another one. Let's go 8 to the negative 1/3. All right, now I threw one of these on our example the other day. So we have a negative exponent, so you got to take it to the basement. Now, normally we would go cubed root of 8, but we should be getting pretty good at this. What's the cubed root of 8? We know it's 2, so it's just 1/2. All right, now I'm going to leave you with some examples to do for homework. Since it's a short video, you've only been with me 7 minutes. So take another 3 to 4 minutes. And what number are we on? I want you to do 7, 8, 9. So 7 is going to be 2 to the 3/4 power times 2 to the 5/4 power. 8 is going to be 4 to the 1/3 power. And let's go 9 to be 16 to the negative 1/3 power. Okay, I want you to work these 3 problems out. Bring them to class tomorrow with your notes and I'll check. All right, see you tomorrow.